Hello, our goal today is to solve systems using matrices. So the first one we're going to look at is what if I asked you to solve something like 3x plus 2y equals 7, negative 6x plus 6y equals 6. So we could rewrite this as a matrix. And the way we do that is in one matrix we write our coefficients, so 3, 2, negative 6, and 6. Our next matrix is our variable matrix, and that equals 7, 6. Because if you guys remember, when you multiply matrices, row by column, so this is 3 times x, so our 3x, plus 2 times y, equals 7. And then our bottom one, negative 6 times it would be second row times that thing. So negative 6x plus 6y equals 6. So we can write it as a matrix. And now over here, this is kind of like saying we have an AX equals some matrix B. So what we're saying is A equals matrix 3, 2, negative 6, 6. Our X matrix is our variable, that's X and Y. And then our B matrix is 7, 6. Now on matrices, normally if we were to solve this, we'd say divide by A, divide by A. In matrices land, to make X by itself, we multiply by the inverse. And if we multiply the inverse on one side, we have to multiply it on the other. And on the same side too, because matrices are not commutative, so we have to multiply it on the left. And what that does, that reduces this, so we have X equals the inverse of A times B. So first of all, what we have to do is find the inverse of matrix A. So if you guys remember from before, our matrix is 1 over the determinant, and then we swapped these. So for A, we'd have 1 over our determinant here, so 3 times 6, so 18, minus negative 12, and times, so if we swap these, we have 6, 3, negative 2, and 6. So we have 1 over 30 times 6, 6, negative 2, and 3. So if we multiply this out, we have 6 over 30, negative 2 over 30, 6 over 30, and 3 over 30. So there's our inverse matrix. So what we have to do is multiply that inverse matrix on each side. So we have 6 over 30, 6 over 30, negative 2 over 30, 3 over 30, times, so 3, 2, negative 6, 6, xy. And again, since our inverse was on the left, we have to put it on the left over here. So 6 over 30, 6 over 30, negative 2 over 30, 3 over 30. Oops, and I'm running out of room there, times, what did we have, 7 and 6. So this is the part where it's like, so this is A inverse, A, X, A inverse, and B. And so these multiply out to be our identity matrix. So we are left with xy equals 6 over 30, 6 over 30, negative 2 over 30, 3 over 30, times 7, 6. Oops, not a fraction. I don't know why I wrote it like a fraction. 7 and 6. So now if you remember multiplying, so this is a 2 by 2, this is a 2 by 1. So our resulting matrix, so whatever xy is a 2 by 1. So I'm just going to write those slots here. So we have some number that's going a 2 by 1 in some number there. So if we remember multiplying matrices, so this spot right here, row 1, column 1. So row 1, column 1. So we'd have 6 over 30 times 7 plus negative 2 over 30 times 6. So fractions we multiply across, so we have 42 thirtieths minus 12 thirtieths. Well, that's just 30 thirtieths, so this is a 1. And then if we go to our second spot there, that is row 2, column 1. So if we go and look at this, row 2, column 1. So we have 6 over 30 times 7 minus plus 3 over 30 times 6. So 42 thirtieths plus 18 thirtieths. So that's 60 thirtieths, which is equal to 2. So our final answer here, we have x equals 1 and y equals 2. And you might say this takes a while. It gets a lot faster. It's really nice for 3x3 ones because we can use a calculator on those. You can always use a calculator to double check your stuff. But let's take a look at one more. So let's say we have 2x plus 3y equals negative 17. 1x minus 1y equals 4. So our matrix, so we would have 2, 3, 1, negative 1 times xy equals negative 17 and 4. And again, you don't have to write out every single step like we did. So this is A, X, and B. And what we know is our X matrix is our inverse times B. So we'll use that information. So first let's find our inverse. So 1 over the determinant. So 2 times negative 1. So negative 2 minus 3. Okay. So, and then we have to switch those. So then it's negative 1, 2, negative 3, 1. So we have 1 over negative 5 times negative 1, negative 3, 1, 2. So we'd have 1/5, 3/5, negative 1/5, and negative 2/5. So there's our inverse matrix. So we know to get our X matrix, we take our inverse, so 1/5, 3/5, negative 2/5. Oops, wrote that out wrong. Negative 1/5, negative 2/5, times our B matrix, which is negative 17/4. And again, think multiplying, a 2 by 2, 2 by 1, so we can multiply those. So x equals, we're going to have those two spots again. Color code those. So we start with, I'll start with the top one. So that's row 1, column 1. So we have 1/5 times negative 17 plus 3/5 times 4. So we have negative 17/5 plus 12/5. So negative 5/5. So we got a negative 1 right there. Oops. And then let's see the next one. So row 2, column 1. So we have negative 1/5 times negative 17 plus negative 2/5 times 4. So we have 17/5. Oh, I thought this turned out to be, well, maybe it does, times 8/5. So 25/5, or 5. So we have our answer, x equals negative 1, y equals 5. What this is really nice for, 2 by 2s can be done by hand. But if you had a 3 variable one, like 2x plus 3y minus 5z equals 8, x plus 2y plus 3z equals 7, negative 5x minus 3y plus 10z equals negative 22. This to solve by hand is such a mess, but it's so nice on matrices because we just take those coefficients, 1, 2, 3, negative 5, negative 3, 10, x, y, and z, 8, 7, negative 22. So this is our A, X, and B. And we know that X equals our inverse times B. So this is where, let me see if I can, I don't know if you'll be able to see both of these or not. So this is where it's nice. So let's clear everything out. New matrix. So 3 by 3. 2, 3, 3, negative 5. Row 2, we had 1, 2, 3. Row 3, we had negative 5, negative 3, 10. So let's strike a new matrix. Was a 3 by 1. So we had 8, oops, 7, negative 22. So we need to do A inverse times B. And then those would be all of our answers, our X, Y, and Z. And I just made these up, so they're not very nice numbers here. So we would have X equal to 5.6, Y equal to negative 0.13, and Z equal to 0.55. Now you might be like, oh, Miss Husing, well, let's just go back up here. You gave us this problem right here. Well, let's double check it. I am going to ask that you do these by hand, so I'll clear it. But new matrix, and if we had a 2 by 2. So we had 2, 3, 1, negative 1. There's our A. New matrix, a 2 by 1. And so we have all our information there. See, we got the 2, 3, 1, negative 1, 17, 4. To get our X matrix, all we said was it was our inverse times B. So we can go here, A inverse, whoops, oh no. Whew, I thought I lost that for a second. So A inverse, oops, inverse times B, and we have exactly what we had before, negative 1. Oops, and it looks like I must have messed up on a negative on that one. So it's nice to double check. We could go back and see where that mistake was. But we had negative 1 and 5. So 2 by 2s I'd like you to try by hand, but 3 by 3s you can definitely use a calculator. And this is one of those things where, especially like for the quiz, showing your work is super important, because like you saw here, 5, and on the calculator I got negative 5, and I don't know where the error was there, but that would be, I mean, you'd get the majority of the points as long as I can see your work.